Hey everybody, Steve Hedden here from Top Quadrant. Today we're going to be talking about Neo4j integration with TopBraid EDG, what it looks like, why we built it, and how it works. So I'll just go very quickly at a high level what it is and why we built this thing, and then I'll actually show it. So at a high level, why this is significant, what this means. Neo4j is a labeled property graph, LPG. TopBraid EDG is a knowledge graph curation tool that's primarily based in RDF and Shackle. And those are two different graph technologies that have historically not been very compatible. And so this is a big step forward in bridging that divide. Why we did this is you get the best of both worlds. You have a single source of truth in Edge to manage your ontologies, taxonomies, reference data, metadata, and then a graph database for high volume instance data use cases, semantic search, recommendations, graph rag. You can do that in Neo4j, but have a single source of truth and a metadata layer behind everything you're building. So let me show visually what I just described. Here's what it looks like. At the bottom in pink, you have data storage on the left. This could be a data lake, CMS, relational database, and then on the right, third-party control vocabularies. We read all that metadata, reference data into Edge to align, to curate, to build against data models. You have your semantic layer there in Edge. What's new is at the top here on the left, Neo4j as a downstream application that you can output those control vocabularies in Edge. You can output them to Neo4j and do all the cool things you want to do in Neo4j. What's significant, and I'll highlight, is this line from data storage all the way up to Neo4j, and we'll talk about this, and I'll show this in the demo. We're only taking metadata and taxonomies and reference data from Edge. The instance data is coming from somewhere else, and that's what I mean by you get the best of both worlds. On the right there, at the top, I also have GraphDB. It's just an example of a RDF-based graph database that we also integrate with. So you could do the same thing there. It's no different. It's just now we also enable you to do this in Neo4j. At the top, some of the potential applications you could build using this architecture: semantic search, recommendation engines, graph rag, graph analytics. I'll be showing a recommendation today, but this is the overall architecture of how that would work. So without further ado, let's get into the demo. Okay, so now we are in Neo4j for the demo. The scenario here is I want to build a recommendation engine for journal articles for students. So for example, if a student really liked this article that is part of is about a subtopic of computer science, and they would also like this other article that's about another branch of computer science. That's all. It's a very simple recommendation engine, and that's all we want to build today. And all we really need to do that is a list of articles that are tagged with topics, and then that those topics are part of a taxonomy that we can manage, and that taxonomy has hierarchical relationships. So there's parent and child, meaning there's sub computer science and then branches of computer science as subtopics or children. You can see here in this Neo4j instance, there are 0 nodes and 0 relationships. It's just an empty Neo4j. That taxonomy that we want to use to power this whole recommendation engine, we're going to manage in TopBraid EDG. You can see it's right here on the left. There's astrophysics, computer science, all these other topics. And yes, parent, child. There's a lot of branches of computer science. So step one, we get this taxonomy from TopBraid EDG into Neo4j. I press a button, it loads it, both the classes, concepts, and the relationships between them. When I go to Neo4j and explore, you can see now there's topics, these resources. Let's, but probably more important here is that those relationships are also maintained, right? So you will be looking at computer science as a parent, and then there's all these branches underneath it. So we've successfully taken the taxonomy, which has an ontology and a data model behind it from TopBraid EDG, and pushed it into Neo4j. That's step one. Now we need to populate it with instance data. The instances in this use case are articles, and so you can import data into Neo4j however you want, or however you would typically populate your graph database. For this demo, I'm just going to drag and drop a CSV right into it. It only has like 15 articles. It's fake data. It's just to show that the instance data is not coming from Edge. The instance data is being populated into Neo4j, and the taxonomy is managed in Edge. Let's do this just to define the schema. And very small data set just to show what it would look like. And now when I go in here, we want to make sure the articles are here. They're in pink right here. Articles, instance data, they're in pink. Taxonomy, topics, they're in green, but they're not yet connected. So we need to run a little Cypher script to connect everything together. I just copied and pasted that, and that ran it. It connected those 15 things with the things that we already tagged with. Now, 15 articles are now tagged with topics from our taxonomy. So now when we check to see those relationships, we could say articles tagged with and everything's connected. This is the foundation for the recommendation algorithm, right? So like these two articles, for example, are in pink, are both tagged with the same topic in green. So they would be considered similar if we were to run that kind of similarity score against them. But what's also significant, or what we'd want to look at and play with, is that these, for example, these three articles are tagged with different branches of computer science, but they're all branches of computer science, right? And so this one's tagged with mathematical software, this one's tagged with multi-agent systems, and this one's tagged with systems and control, but they're all parts of computer science. Those topics have computer science as the parent node. And so let's try that. Let's build, say I really liked Advances in Mathematical Software Studies number 7, could not put it down, loved it. I want to read the next, whatever else you got that's as similar as possible. We can run a little query in Neo4j to find something similar. So you can see here, I just copied and pasted this in. This is that article. Find me other similar articles. And based on what we were just looking at, we should return those too. There they are. Now again, they weren't tagged with the same topic. They were tagged with multi-agent systems and systems and control. But they both are branches of computer science. So suppose I actually made a mistake in my taxonomy, or I want to change something in my taxonomy, or some policy or regulation has changed that has forced me to change something in my metadata. I can come in here and say, we accidentally put computers and society under astrophysics. That should really be under computer science. I can drag and drop that. It has a new parent node. And so I made that change in Edge, and now we want to see what the consequences are in Neo4j. Before I do that, I do want to highlight that we have a Cypher query here, and I can run queries from TopBraid Edge against my Neo4j instance. And so if I run that, you could see that right now it says that the parent of that computers and society, the parent node is astrophysics in Neo4j, whereas in here in Edge, it's computer science. But I'm going to push these changes downstream into Neo4j. Now let's check to see if it worked. I could check from Edge by running the same Cypher query. Yeah, there it is. It says computer science now. So how do we know that matters, or why do we care at all? Because now if any article was tagged with computers and society, it should now show up as a recommendation for those articles we were just looking at. And so let's see if that works. We run the recommendation engine again, and now we have a new recommendation because this was tagged with computers and society. And that is now considered similar because of its relationship to computer science. The very last thing I will show is that this also works in GraphDB. And that's the architecture I showed at the beginning. That same algorithm I have implemented here in Sparkle rather than Cypher, but you could see it's been run. This is pre-run for multi, and the same results came back for that same article, right? So it's the same data. Now it's just GraphDB instead of Neo4j, the same recommendation engine, the same results. I made the same change in Edge. Now I push a button from here, and when I rerun this algorithm, the exact same article now appears here. And so we made one change in Edge, pushed them downstream, and saw the result in two different recommendation engines powered by two different graph databases, one a label property graph and one a graph database based off RDF. And so we have a single metadata management interface in Edge to manage all different graph database applications, including Neo4j. So last slide, I'll just end with this. Let us know what you think. Test it out. Try it. If you're an existing customer, let us know what you think through the service desk or email product directly. If you are not an existing customer, reach out to the team, either sales or product, and we'll schedule a call, show you what we have, and love to work with you more. Thanks and goodbye.